Hello, everyone. How are you doing, Mama? It's good. I'm doing okay. A little down today, but hopefully doing some Sudoku will help me pick back up. Have you done anything exciting since last week? Nice. How was it? See any? Nice. Juice. Oh, wait. I clicked on the wrong buttons. Um, we gotta start all over. Hold on. Starting soon. Talking. Hello, everyone. How are you doing, Mama? I didn't
I'm
click
doing all
your
right.
voice on.
Oh well.
Yeah. You said you went to Shades on Saturday. You said.
Yeah,
Yeah. Um, you said it was
it was a
a
good day to
nice.
go.
Mhm. Did you see any neat frogs?
No,
No. Um, did you see anything neat in general?
I mean it was basically a walk around a state park with Savannah. So
Hmm. Sounds fun. Um, I haven't been up to anything fun, so think it is Sudoku time. I think I want to get in here now. Alright, Sudoku. Uh-oh. Let me grab the browser. There we go. Now we can transition over there. And we can start with our first puzzle today, which is going to be Vortex by Donatello86. Normal Sudoku rules apply. Digits in cages sum to the top left corner of the cage. Digits do not repeat in a cage. Digits along a green line have a minimum difference of 5. Cells separated by a white dot have consecutive digits. Cells separated by a black dot have digits with a 2-to-1 ratio. Alright. Pretty straightforward rules. So, this 15 here, I have to put digits that sum to 15. It might be 4, 5, and 6. It might be 6, 3, and 6, 2, and 7. Stuff like that. When it comes to these green lines, if this digit is, say, a 2, I would have to put something 7, 8, or 9 in the two squares that are adjacent to it along the line.
well,
And
that
then on
center
these,
digit's going to have to be a 1 or a 9.
yep. And with these arrows, if I put, say, this isn't going to work, but let's say I put a 6 here, then I would have to put 1 and 5, or something similar to that, because 1 and 5 sums to 6. Cross a cropy dot, or these white dots here. White ones are consecutive, so they have to be like 2, 3, 3, 4, stuff like that. And then a black dot would be in a 2-to-1 ratio, so if I put a 3 here, 3 times 2 is 6, and they do like that. I think that's all of the rules. Restart real quick, and center here has to be 1 or 9, because it's got 4
Well,
digits. Go ahead.
yeah, go ahead.
It's got 4 digits around it, and let's say I tried to put an 8 here. You can do 1 and 2. You can also do 3, but that's as far as you go. 4 is 4 away from 8, so that wouldn't work. And the same thing for 2. 2 plus 5 is 7. 7, 8, and 9 doesn't get you 4 digits, so 1 or 9 here.
I've seen a couple of things.
Yeah.
The
What?
center digit is going to
Mhm.
have to be low
Yeah.
because if it's high, then there's going to have to be a 9 on one of those because you're going to have a 4 on one of the inside ones.
Right.
And then also, there's a 35 cage starting in box 1. It's a 5 cell. And there's a black Kropke dot. Yeah.
So, of course, 4 or 3 there. And since this is even, this one across the white Kropke dot cannot also be even, because you can't have 2 consecutive even digits. Oh, 6, 7, 8, and 9 makes that a 5. This 28 cage, no, these 31 cages, can I put a 2 in there? I don't see why not. 6, 7, 8, and 9 is 30, and 2 would be 32, so I would only have to change a 6 into a 5. But we know that these are low digits, 1, 2, 3, 4, and wherever the 6 is going to force a 1.
Well, and those circles cannot be...
The ones in the corner?
they're 7, 8, or 9, yeah. They can't go down to 6.
And because the minimum in 6 digits is 21, if you sum up the values 1, 2, 3, 4, 5, and 6, you're going to get 21. It's a mathematical property called a triangle number. Since there's 3 of those lines, dividing 21 by 3 gives you 7. As a quick way to calculate the minimum there. Well, if this is an 8... Oh, never mind. I was going to say if this was an 8, that this couldn't be 8, 4, but that doesn't follow, because this could be a 9, and still allow this to be 8 and 4. Because an 8 would require it be a 4, 9 pair on the off of the arrows. But since it's 9, 4, 4, 8 doesn't block both options.
Right.
These 15s. We know that whatever this number is, it's going to be doubled. And whatever this number is, it's going to be doubled. And with the 15 here, means the remainder in both of these columns is 30 in each column left. Because the full column is 45. Subtract out 15 is 30. Divide by 2 to get the sum of the top and the bottom is 15. So they're a 7, 8 pair. I see the 15s in the rows as well. The same logic would apply if you went along the rows. Right. Because let's say I tried to do 7 and 9. Well, a 7 doubled, because these two would have to sum to the 7 here, would give you 14. A 9 would be an extra 18 and 15. Well, this would be 1 less than 30, but this would be 3 more than 15. So that would end up with a total of 2 more than 45. It's a weird way to add that all up, but since we know we have to get to 45, and 45 is 3 sets of 15, having one less than 15, one that is 15, and one that's 3 more means the one less and the 3 more combined to be 2 more than 45 in total. Probably over-explain that. That's fine. But that does mean that we have to have 9s off of the arrows. You can't put a 9 on an arrow because it would have to add with at least 1 to make 10, but we are only limited by single-digit values.
And the 2 corners that have the 7s, the off of the arrows are going to be 8, 9, and the one that has 8 is going to be 4, 9.
Right. So we can actually say that this has to be 4, 8, 9.
Right, but in that 35 cage, it can't be a 4.
Right. Now, that means that these 15s have to have 9s in them, which is actually going to take the 9s out of these two, and that's going to place a 7 and a 9. 9 from those places. These two aren't 7. This one's a 9. Which places a 9 here, which places a 9 here, which places a 9 here. Which, actually, I took the 9 out of that one. Could have placed that one. Doesn't really matter. But then the 9 would be paired with 1, 5 or 2, 4. And that's true for all of these.
Column 5 has a 2, 3, 4, 9 quad.
6, 8, and 7 is left over then? Is that right?
Yeah.
And then a 7 can't be on the black crocky dot down here because 7 times 2 is 14, and 7 is odd, so you can't divide it by 2 without getting a fraction, which is going to leave a 7 here because of the created 6, 8 pair. And
2 or 4 on the other side of the crocky dot.
right. And 3 or 4 is not consecutive with 1 or 9. I guess this is just 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, and 5. Means this top digit's a 9, isn't it?
Yep. And that's a 2, 4 in box 2 with the 9.
Right. So that's a 3, a 6, an 8. 2, 3, 4 makes a 1, 5. Takes the 5 out of here. 6 is going to be a 3. Those aren't 3s. Those aren't 6s. 2, 4 pair makes that a 3. That's a 4, which means this has to be an 8. And then these two are 7s, and that's an 8. Places a 4, takes the 4 out, takes the 4 out. 4, 5, 6, but it has to be a 5, so that's a 2. These two aren't 2s, which makes it 7 and 5, which neither of them could be 5, so they're both 7. And these two are both 1s. 1, 5, not a 1. 2 or 3 would be 4 or 5, but it can't be a 4, so that's a 5. We're paired with 2. The 4 is going to have to be used with a 3, so this is an 8, and so is that. Column 6.
The empty spot's an 8 because it's a 6, 7, or 8, and it sees both 6 and 7 in the box.
Right. Well, this is going to be 1, 5, or 2, 4, except this one sees, well, 3 of those. So that
Yeah, and
is...
there's an 8-9 pair in column 4, so that's not a 9 on the bottom.
That's going to place the 9 here. I need 1, 6, and 3, 4, where this is the 3, that's the 4, this is the 6, that's the 1. We're going to have 3, 5 here, which is going to go this way, and the other is going to be 2, 6, which is going to go this way. 2 and 4 is out, 4 and 2 is out, 2, 6, 5 and 3. I need a 1, 6, which is going to be over here. 1, 6, 3, and 4, which is going to... I see the 3 over here, which is going to place the 4 on top. 1 or 9 means that this... Well, it can't be a 9 and an 8, because that would break this 8, 9, and I see that this is a 1, 9, so this is actually an 8. But you can't do 9 then 8, because you already got that one, so this is 1 and 2. 5 and 9, 5, 9, 1, 2, 4, 2, 4 and 2, 2 and 4. These two, well, I need a 3 over here, which isn't this one. 1, 2, 3, I need a 4, which is going to be over here. 5, I need a 6 in one of these two. A 7 is going to be over here, and 8 is going to pair with the 6s. 6, 8, 7, 6, not a 7.
Well, that's a 28 cage.
Yeah.
And you've got 17, so that has to sum to 10.
10,
so it's
which
3 and
has
7. Well, that's a problem.
Wait, you said this was 17?
15, 17. It sums to 11, sorry.
4 and 7 and 3. There we go. Alright, I was about to be very sad.
Yeah, no, I apparently 17 and 10 is 28, so.
7 and 8, and we're done. Nice. That wasn't too difficult. Yeah. I really like the way that the mathematics really shines. Like the fact that like with these seeing that you had to have a 7-8 pair here was like the really key insight that got a lot of it going. And then also like what it left in the gaps of the arrows. A few other things here and there, but that was kind of the along with this one that you saw early on. But yeah, all right. Anything else with this puzzle?
No.
Right.
That was.
Yeah, I really like that one. I like the quick puzzles, even if they're easy. Like technically, I wouldn't necessarily call this one easy. Like just because we got through it quickly doesn't mean it's easy. One of the things I like to reiterate quite a bit, but because I think that mathematics here in the columns that I saw, in the rows technically, though, that's not an easy thing to spot if you're not comfortable with that logic already. But anyway, next puzzle is going to be Buddy System by Rismith. Hopefully I said that correctly. Normal Sudoku rules apply. Squares are friendly cells. Friendly cells contain a digit that match the row, column, or box number. All friendly cells must be orthogonally adjacent to a buddy digit. there is a single buddy digit for the puzzle. The buddy digit happens to be a friendly digit 3 times, and of course does not appear next to itself in these instances, and is never marked with a square. All other friendly squares are given. Okay. I'm not sure I fully understand the rules. How do you feel about them, Mama?
Yeah, I'm not friendly. I mean, I know friendly.
Yeah, the friendly, it's the buddy ones that I'm uncomfortable with.
Authority to a buddy digit.
I don't know. I guess we hit start puzzle and then we look at what's going on. So the friendly cells are easy enough. If I go in here and let's take a look at this one. It's row, or I guess because there's some overlap here. I guess it doesn't really matter. It's row, so counting from the top, 1, 2, 1, 2, 3, 4, 5, 6, 7. It's column, 1, 2, 3, 4, 5, 6, 7, 8, 9. Or it's box, which would be 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this can be 7 or 9 because it's in row 7, column 9, and box 9. Now, we would have to have a buddy cell, which would be one of these two. Let's mark that in green, because green's a friendly color. That would have to be orthogonally adjacent. Although it doesn't say it has to be orthogonally adjacent in the box itself. So I guess it could technically be up here. Now, like this one, you'd have to have it in one of those. Now that buddy digit, let's say it is the 5, would mean that we have a 5 as a buddy digit 3 times. So that would be once for the row, once for the column, and once for the box. And you can't duplicate any of those, because if it was doubly friendly, it would only happen to be a friendly digit 2 times total. So let's say I put it like here in the center digit. Well, that was the box, the row, and the column. So I couldn't make it friendly anywhere else, because it wouldn't be friendly here, and it wouldn't be friendly in any other box, and it couldn't be friendly again in the column or friendly again in the row. So it has to be once each. Okay, I think I'm understanding it a little bit better. What do you think? Because the buddy digits aren't marked with squares. Okay. But they're still friendly 3 times. Okay, so these starts, we have an accurate time. And I guess I'm just going to highlight where all of the locations a buddy digit can be. Well, we have to have one here, one there, one there. Now, this one, you can't have its buddy digit be here, because this one has to be orthogonally adjacent in one of those. So this one could be here or there. Now, the buddy digit is never marked with a square. So for this one, the buddy digit would have to be one of these two, because it can't be a square. And it can't be here, because then this one wouldn't have a buddy. So then it isn't allowed to be here. Now, what about this one's buddy? It can't be a square. It can't be here, because then this one wouldn't be allowed to have a buddy. Because whatever the buddy is, let's say the buddy was 3, well then you'd put a buddy here, and then this square wouldn't have one. So this one has to have its buddy be here, and it can't go here, and now it can't go there. So now this one's forced to be our buddy. And we get a buddy square in one of those two positions. Okay. So then... oh, since it has to be one of those two, this one can't be it.
Well, and look at box 3. There's a buddy cell on the top row. So unless it's on the left, the square that's in row 2 of that box wouldn't be able to have a buddy.
So that eliminates the 5.
Right, because its other options are either in the same box, which you can't repeat the same, or it would be on a square. So.
Okay. So now, well, for this one, I guess it could be the 8 still. So, alright, in here, can't be there or there, so you can have buddies there. In here, it can't be there, it can't be on a square, and it can't be there. This one's not even next to, well, this one needs a buddy, and it can't be there, so it has to be one of those two. This one needs a buddy, and it can't be here, here, or there, so it has to be that one. So that rules out those. We know it has to be one of these two. Well, this one needs a buddy, and it has to be one of these two. Well, we know that that one rules it out of there. So it ruled it out of both of those, so that's a buddy. And now our buddies have to be in one of these positions. And then just to make sure, okay, so these ones have buddies. Those have buddies. These have buddies. These two have a buddy. Those have buddies. This one's got a buddy. Okay. If this one was the buddy, then this one wouldn't have one, and neither would this one. So this one isn't it, and this one is. So now those all have buddies. And again, this one wouldn't allow that one to have a buddy. So we ruled that one out, and now these have buddies. This one rules that one out, and now this one says these have buddies. Okay, now to take it out of the squares, just to remove some of the confusion that might have caused. And that should be our 9 buddy squares. 3, 6, 7, 8, 9. Now, it's a buddy exactly 3 times.
No, it's friendly 3 times.
Right, that's what I meant. So I guess here it's in box 1, column 2, and row 3. This one, well, it's in box 2, row 2, and column 5. This one is box 3, row 1, column 7. box 4, but it can't be the friendly with 4. Column 1 and row 5. Box 5, column and row 6. Box 6, row 4, column 8. Box 7, column 3, row 9. Box 8, but it can't be an 8 because of the 8 over here. Column 4 and row 7. Box 9, column 9, row 8. Now, I see 3 1s, so 1's a possibility. I don't see 3 2s, so 2 is out. I do see 3 3s. I see 2 4s, so 4 is out. 1, 2, 3 5s. 2 6s. 3 7s, so 7's a possibility. I only see 2 8s and 2 9s. Actually, I want to remove the center values because they're all the same. Oh, we can't do 5 though, because 5 would break. So it's 1, 3, or 7. And regardless, this one is going to be a 1, 3, or 7. Alright. That all felt logical, right?
Yeah.
Okay, so now this one is box 1 and row and column 2. Because we know that this one's a friendly cell. These are all box 2. Column 5, column 6, row 1, row 2, and row 3. Box 3, column 7 and 8, row 1, row 2. Box 4, column 1, column 2, row 4, 5, and 6. Box 5, row 5, row 6, column 4, 5, and 6. Which I guess means that those are a 5-6 pair, and that's going to place a 4 here. Anyway, box 6, column 7, column 9, row 4, row 6. Box 7, columns 2 and 3, rows 8 and 9. Can't do 8 because of the 8 already there. Box 8 only applies for this one. Columns 4, 5, and 6, rows 7 and 8, which I guess this has to be 8, because it's in box 8, row 8, and column 4, and it already sees a 4, so that's an 8. And now this one, it's box 9, column 9, and row 7. Well, 7 is interesting. Because if I were to make this a 7, it would go 5, 6, 9. 6 and 5 and 2. 1, 3. Hold on. If I did 7, we've got 5 and 6 and 9. 6 and 5. 2, 1, 3, 1, 3, 8, well, that would be a 7, so this would be a 6. And that's where it's broken. Because you'd end up with 2 6s here. And 2 1s here. Or wait, no, that's not how that works. That's a 7. It doesn't matter. We'd end up with 2 6s if I used 7, because this would end up being a 5, which makes that a 6, and that's a 6 because that's a 7. Take out all of that, and we lose 7 from our buddies. One or 3? Well, a 1 would make both of those 2s. So let's try that. If we did 1s, we'd have 2 2s, a 4, a 6, a 5, a 7, a 7, a 6. But then these would both be 6. Because a 1 makes a 6, makes a 5, which then makes that a 6, and this being a 5 makes that a 7, which makes that a 6. And you can't have 2 6s. And also this one's a 6, because of the 2. So lots of ways that one's broken. But that means that our buddy digit is a 3, unless I did something terribly wrong. Which is not impossible. But along that, this can't be a 5, because this would be a 7, and I'd end up with 2 6s. So this is a 6, 5, 1, 7, 2, 6, 1. 2 4 pair makes a 9. That being a 6 makes this a 7, a 5, a 9. Not a 9, not a 7. A 4 6 pair places a 2 and a 4. This being a 5 makes that a 2. This a 1 and an 8. And we are rapidly approaching conventional Sudoku. Okay, let's take a look down here. 1, well, 1's out of everywhere but there. 2's is out of everybody there. 5 and 6 is left over, and this 5 fixes those. Well, that's 1 through 4.
2 needs 7 and 8.
And this 7 fixes them. And I guess the 8 does as well. So this is an 8, and this is a 7. This 8 is there. So then column 1. 5, 6, 7, and 9. Which, of course, the 7 in box 1 places it in box 2. But that's not enough for there. So
Row
the remainder is 7.
Needs a 2 and a 4. And there's a 2 in column 7.
Finishing box 1, I think I need a 2, 4, and 8. Which these can't be 2s because of those 2. And so this one is a 2. This is the 4, 8 pair. 5, 6, and 9, I think. Where these two aren't 6s, so the middle one is.
Interesting. Those were roping.
Sure were. 4, 8, 2, 4, 8, 2, 4, 8. We have that across the rest of the puzzle, 3, 5, and 7.
Well, if the 6 in box 8 is placeable.
6 in here, not there, not those. This is a 6. One, 2, because of the 1, 2 here, and this 2 fixes it. So that's what, 4 and 9?
4 and 9.
These 4 and 9 fix those. What's left over? A 1 and a 6. And that 6 fixes it. 5, 7, and 8, which are not done. 7, 8, and 5, those are all different. These two are 5, 8, and, well, this one's not 5, 8, so that one's an 8, that's a 5, that's a 7, that's an 8, and this one
9.
is a 9. So those 3 are all still different. What's left over in these 4?
Well, row 6 is 2, 5, 9.
2, 5, 9, where that one's a 2 and that one's not. I don't see a 1, so then 5 and 9 are still there, but 5 and 9 make that a 1, so this is a 9, that's a 5, that's 9, that's a 5. These 2, I don't see a 2 in that row, and I don't see a 7. This one's done. It's an 8. 1 needs to be over here, and I think 9's the last digit. These 2 are 4 and 8, where this 8 fixes them. 4 and 8 there. I need a 5, 7, and 9. So that's a 9. So that's gonna fix those. 5 and 7 then. I need a 1 here, a 4 here. 5 is there, so 6, the upside down version of 9, and 7, and that's it. Nice. I did find Buddy System first on Cracking the Cryptic, but I also found it on Logic Masters Germany. So then let's plug in row 7 here. 861, 357, and move my notepad over so I can plug that in. Uh-oh. Row 7. 6, 1, 3, 5,
You have
7.
929 instead of 429.
There we go. Just take out the duplicate 9. There we go. I thought that was at least average. While it was fairly quick to work through, it's still a fairly complex thing. Like, we were both, like, unsure of the rules at the very beginning. Although I think after sort of playing around with them, it was fairly straightforward.
Yeah.
But even then, like, it still took some finagling around the grid, although we probably could have done it faster. I think the logic itself, the fact that it's not, like, straightforward, makes it a slightly more difficult puzzle. It's probably going to be that I'm going to rate a lot of these puzzles higher than what most people are rating. Although I'm probably not going to be rating them like 5 stars if other people are rating them 2 stars. But who knows? I'm going to go with average there. Because it did take like a few attempts to take a look at what was going on. Although we probably could have looked at this and seen that it had to be a 6 based off of the other stuff that was going on and how that would impact things, because I think this being a 6 forced that to be a 1 and that to be a 7, which would force that to be a 3 faster than the way that we went about it. But I don't know, like some of those things, it's just sort of like what you see when you see it and all of that stuff. So, anything else on this puzzle, Mama?
No, that was good.
All right, then, puzzle number 3 for today. Wake Up by Pete Craig. Normal Sudoku rules apply. Each row, column, and 3x3 box contains each number from 1 to 9 exactly once. Digits along the blue line sum to the same total each time it enters a new box in the grid. The digits in each circle must appear at least once in the 4 surrounding cells. Alright, fairly straightforward rules here. If I see a 3 in this circle, it has to be in here somewhere. Can't put a 3 here because it would rule it out of all of those. And then with these blue equal sum lines, let's say I make this a 6, then this would have to be 1, 5, or it could be 2, 4. And then you'd have to do something similar over here. And seeing with the quadruples that that's a 2, 4, it would have to be something like that. I think that's all of the rules. So let us begin. Well, these quadruples that have 4 digits have to be those 4 digits. 7, 1, 2, 8, 9. 5, 6, 7, 8, 9. Now, this 7 and that 7 rules 7s out of there, and this 7 and that 7 rules it out of those two. It places a 7 up here. 2 and 4, and 2 and 4, I mean 2 and 4 is here.
Well, and the 7s, well, no. Never mind.
I see 3 and 4 in both of these quadruples, so that places 3 and 4 up there. 2 is matching between these two, so it's going to place a 2 here. Same here, 2 and 2. It's going to place 2s there.
2s in boxes 1 and 3.
Right. I did see that. But had forgotten about it until you pointed it out again. Now, looking at these two, I can't use 7 and 8 in either of these. Because you can't do 7 and 8 together. That's 15. But 7 and 3 is 10, and 8 and 3 is 11. And using a 4 doesn't help. So 7 8's off of both of those. 3 4's off of here, and we're forced to place a 7 here. Because 3 and 4 is 7. So in here, our 7s are going to end up off of this blue line. But here you can do 7 and 2 to make 9. You can't put the 9 on there, so it has to go over here. You can't put a 9 on the blue line. But I have to put an 8, which is going to mean it's a 1 8 pair to make 9. But if I did 1 2, that would be a 3. But I can't do a 1 2 here because we've already shown that it had to be over here because this 2 and that 2 ruled it off of there, so I wouldn't be able to make 3. So this is a 9 and this is a 1 8 pair, and 1 and 8 are off of the other two.
Which places the 9 in box 6.
Sure does. It's a 9 out of box 3, although it's not placed yet. But this 9 rules it out of these two, so we get a 9 in one of those two, because it's not on here, and takes the 9 out of this one. We get 9s here, places a 9 in box 9, and
in box 6, if the 7 were on the blue line, then it would have to be paired with 1, because it can't be paired with a 2 because 2 is in the third column, but that would make 8 and you cannot make 8 from what is in box 3.
Right. So that places the 7 here then, right?
Right.
So, well, we know that this is maximum 6 because it can't be a 7, and also 1 and 2 are not allowed because those are minimum 3. But again, 2 is over here because 2 and 2 mean it can't be in there, so 3 is not allowed. A 1-3 pair would be fine, so it could be 4. Although if that's a 4, that's a 4, that would be 4, that would be fine. 3 would be a 3 and a 1 and a 2. Yeah, 4 is one of those
9,
two. Box 9.
The 7 can't be on the blue line because it would have to pair with 2, which would be 9, and there's already a 9 in.
Right. So that places the 7 here because we already ruled out of those with that. What's left over here? 1, 3, 6, right. And 8.
And 4 and 5 can't both be on the blue line in box 9 because that would be 9. So 2 has to be on there.
And it can't be 2, 5.
5 because that would be 7. So it's 2, 4 for 6. Which makes 5 the last one in, yeah. And the 3 can't be on the blue line in box 8 because that would be 3 and 3 for 6.
Right.
And it can't be 2, 4 because the 2 is on the bottom row, so that has to be 1, 5.
1 and 5. It's going to be 8 and 1. Not 1, not 8. Nine, 2, 1, 4 is missing. 5 is not in either of those. I'm missing something else. I think it's a 7. Not a 1, not a 6. One, 3, 4, 5. But
and it can't
not
be
a 5.
Box 1. It can't be 3, 4 on the blue line because 3 and 4 are both in row 1.
Right. But the rest is still fine. Now this, because of the 2, 4 that is from these two, makes this have to be 1, 3. Because it had to be from 1 through 4, because that's the options to make 5. But a 1, 3 pair makes this a 4. 3, 4, which is going to make this a 3 and a 1. 1, 3, 2, 4. 1, 3, 2, 4, 1, 3. 1.
3, yeah.
5, 6, 8. 5, 6, 8. Doing lots of upside down letters now. 2, 5, 1, 6, 5, and 2. Not a 5, so we have 2 options for 5. That's fine. 9 and 2, and not a 4, not a 5. What's left over in here? Well, 2, 9. Well, this one's not a 9. But I also need a 1, 2, 3, 4, 5, 6, 7, 8. None of those are 1. So that actually makes this a 2, 6, 5, 1, 9 pair. 5 and 6. 6, 8, 9 makes that a 5. That's not a 5. 6, 8 pair. This is 2, 4, and 7's already
8. Nope.
5.
Yeah, something.
That one's not a 2. I don't know how Simon and Mark make scanning so easy.
Yeah, column 4 needs 3, 4, and 8.
3, 4, 8. That one's not a 4. That one's not a 3 because it still has to be around the quadruple. 3, 4, 5, 6, 7. Not enough. 7, 8, 9, and 1. Where this is an 8 or 9. 6, 7, 8, 9. 6, 7, 8, 9. Where neither of those are 7. The 7 has to be around the quadruple. 1, 6, 7, 8.
Row 8 needs 3, 6, 7, 9.
This one isn't 3 or 6. And nope, that's it. 3, 4, 6, and 8. But 3, 4, and 6. 3, 4, 6, 8. Yeah, I didn't mess that up. That is an 8. A 4, a 3, an 8. A 7, an 8. A 1, a 7. Not a 1. These two aren't 8s. This is a 6, 3, 8, 9, 8, 6, 8, 6. 4 and 7, not a 6, but those aren't done. This one isn't a 3, neither of those are 7, 9, 6, 2 and
7.
7? 2, 7, 1, 9, not a 4. This one is a 5, I think, which makes that not a 5, but those aren't fixed. 1, 2, 3, 1, 3. What's up here? 3, 4, and no, wrong
8.
digit. It's not the middle one. 9. Well, it's not very restrictive here, but
Well, it can't be 2, 7 because there's a 2 in both columns. And there's a 1 in both columns, so it can't be 1, 8.
And that's not 4, that's not 5. 6, and it pairs with 3. Now let's do this column. 3, 4, 5. 3, 4, 5, 6, and 7 is remaining. But that's not a 5. This isn't 3, 6, or 7. And I think none of these are 7, so that is 3, 4, and 5 makes that a 6, 3, 5. Not a 3 there.
Column 3 is 4, 6, 8, 9.
6, 8, 9, which places a 9. 6 and 9, 4, 8 pair places a 6.
Pairs with a 3 for the knot to make 9 on the blue line.
Right. 2, 3, 4, not 2, not 3, 4, 8, 5, 4, 3, 2, 5, 1, 2. I need a 1, which is going to be up here, and an 8 to finish the puzzle. Nice. There's a little bit of mathematics with the equal sum lines. But I think quadruples really aren't that difficult when it comes to Sudoku. So I think this one I would actually rate. It's not on Logic Masters Germany, unfortunately. But quick spoiler. However, I would rate that one as an easy, but not quite very easy. Just because the little bit of mathematics and how you have to think through that a little bit. Not that I think that mathematics is particularly hard, but that it adds an extra step beyond just canceling things out because they match. Because like in here, like it's just these have to be from the digits 1, 2, 3, and 4. Which is, I mean, fairly standard Sudoku logic. And insofar as like the numbers are just like a useful, like when it comes to quadruples, if it was just quadruples, you could replace all of the digits 1 through 9 with random symbols. They could be letters, they could be anything else, and it's still logically sound. But the equal sum lines add an extra layer on top of that, where it has to be mathematically connected, which makes it slightly different. Which is the reason why I would go easy, easy rather than very easy, even if most people would probably rate that very easy. But yeah. Anything else on this puzzle?
Nope.
Cool. And our next puzzle, Walking in a Circle by Fractal Minding. Normal Sudoku rules apply. A pink Renban line contains a set of non-repeating, consecutive digits in any order. Digits along a yellow thermometer increase from the bulb end. Each pair of adjacent digits along a blue line consist of one even digit and one odd digit. Part of the grid is covered with fog. As correct digits are placed, the fog will clear from cells surrounding the correct digit, revealing additional clues. Unfortunately, my mind wandered while I was reading somehow, and I forgot like half of it.
Typical Renban.
Yeah.
Typical thermos. And blue line is even odds, alternating.
Okay. All right.
And of course, fog.
Okay. So, if I were to place a 3 here, then I wouldn't necessarily have to place a 4. It would just have to be 4, 6, or 8. That would follow. Now, because the thermo, I have to pick a larger number, I couldn't use 2. Now, also because of the thermo, I wouldn't be able to use 8, but that's how that would work. The Renban here means that they can be the digits 1, 2, and 3. Now, because of the odd-even thing, that would mean that the 2 would be in the middle, and the 1 and the 3 would be on the ends. But let's say I instead did 2, 3, and 4, you would end up with the 3 in the middle, and the 2, 4 on the outside, because of the parity line that is the blue line. And then as soon as we get a digit correct, the fog will clear. And I also noticed this is a 6x6 Sudoku, so we probably don't have that many values. So let me go ahead and restart this. So our time starts now. And because of the 1, 2, 3, 4, 5, 6 here, then clearly we don't have 6, 5, 4, or 3. 2, 3, 4, 5. We could put a 3 here. So 1, 5, and 6. 1, 2, 6, and 1, 2, 3. If I did 1, I could do 2 or 4, 3 or 5.
You can't. Okay, if you look at the bottom of that, you can't go 3, 4 on looking at the bottom 2. If you have 3 and 4, then you can't fill out the Renban.
Right. It has to have either of 3 or 4 on it. So you can't put a 4 here.
And you can't put a 3 because it's going to have to be followed by either 4, 5, or 6.
Right. Now, because we have to have an odd, 5 is required as one of those two digits. It
Right.
can't be 4, 6. So 1, 2, 3, 4. So 2 and 3 is on here. Two and 3, and not a 5. So could this be 1, 2, 3? You have 1 and 3, 4 or 6, 3, no, 2, 1 and 3, 6 and 5. I think that would work. Whereas if this was 2, 3, 4, you'd have 5, 6, and 1. So this can't be a 4.
It can't. Well, it can't be 2, 3, 4 on the Ren band, because if it was 2, 3, 4, the evens would be on the outside.
Yeah.
Which would have to be followed on the thermo by an odd, which would be 5
and 4.
And 4, so it can't be 2, 3, 4. It has to be 1, 2, 3, with the 2 in the middle.
Right.
And since that is odd, it's going to have to be the 6 on the thermo.
No, 5, 4. And not a 3, even. Not a 2. One, 2, 3, 4. Four and 2. Well, this can't be a 1 then, because you couldn't put a 2. If this was 5, 6, that's a 4. But whatever this digit is, this cannot be the 6. Because it would have to be 4, 5, 6, and you'd have to put 4 and 6 next to each other. And this can't be a 1. Well, this can't be a 2, because if this was a 2, you'd have to put an even over here, and it would be 2 and 6, which don't connect. And again, you can't put a 1, because you'd have to put a 2 here, but you can't.
Well,
you can't put 3, a 1 here, because it would have to be next to a
3. The right hand on that one, if that's a 3, there's no 4 to follow it up on the Ren band.
Right. So this is a 4, a 2. And we got rid of all of the even options on here, so this one has to be a 6 now. Even. Connects with a 5. And then this is 2 or 6. This is 1, 3, or 5. Even on even, 2, 4, 6, not a 6 because of the 6 below it. Well, we know that this has to be 2, 4, or 6, not a 6 because of the 6 below it. This has to be 1, 3, or 5 because of the even below it. This has to be 2, 4, or 6, not a 2, and 1, 3, or 5.
Well, the thermo you can finish.
Oh, right. It's a thermo. 1, 3, 5 makes it a 3. 2, 4, 6, not a 6. 1, 3, 5, not a 3. 2, 4, 6, not a 2. 1, 5, 2, 4, 6, not a 4.
And that 1, 5 there it can't be a 1 because that's the tip of the thermo and not the bulb.
Six, 2, not a 3. Odd, 5, 2, 6, 2, 6, 3, 4, 1, 5, 3, 1, 4, 6, and 5. Okay. A fairly simple Sudoku there. Yeah. I don't know. I think I would end up saying that this one's average, just because of the like, even though we did it in less than 7 minutes, like the odd evenness, the Renban, and how like those options had to like we went through the logic quickly, but just because we went through it quickly doesn't necessarily mean it's easy. I don't know. That's my justification for not marking that as a very easy puzzle, which it is over here on Logic Masters Germany, so let me go ahead and do that. Row 1. What's wrong one? 4, 3, 2, 5, 6. I will mark that as average. Is still a very nice puzzle. Yeah. Yeah. I think I'm going to stick with my average rating there, unless you want to try and argue me to go with easy.
No, I'm good.
Not certain. I don't know. I think unless I end up like getting to a point where like I think the only way to advance in the puzzle is to like do super fiddly stuff. I have a hard time looking at this puzzle is very nice, like the quality of the puzzle as either being a binary I liked it or I didn't like it. I think there was one puzzle where we started doing fiddly stuff and because we did fiddly stuff, I decided it was nice rather than very nice. But I mean, as long as you get through the logic of the puzzle, I have a hard time, like, being like, I thought that puzzle was not good. I don't know. It's like, I don't know. I'm not sure exactly where I'm going or like how I'm trying to explain myself here. But I don't know. Like, what kinds of things would you consider for like the quality of the puzzle?
Yeah.
Can you think of anything other than just like it being sort of a binary, like you liked it or you didn't like it?
Yeah, that's pretty much what it is. Is it just and for the most part, I like them. So, but because I don't think we've come across one that I haven't actually liked. I mean, there've been a few that have been kind of meh, but
Alright. We still have some time, so let's go ahead and take a look at least one more puzzle. This one is going to be Magical Clock by Jeroen Panda? Hopefully I said that correctly. How would you say that one, Mama?
Jaren, maybe?
Alright, hopefully one of us is correct. Normal Sudoku rules apply. The box 5 is a magic square. This means that every row, column, and the positive and negative diagonals, or the main diagonals, all add up to the same number. Digits an equal distance from the center of a lavender zipper line must sum to the digit in the middle of that line. You cannot use the same sum to make the total on the same line. For example, 8 can only be 4 plus 4 once. Okay, so it's a zipper line, but with the added restriction that you can't copy the value. So you can't do 4 and 4, you can't do 1 and 7 twice.
Right.
And the arrows at the side of the grid are little killer clues, which indicate the sum of the digits along the arrow. Or along that diagonal, rather. Yeah, alright. I think, just to reiterate the rules a little bit, that if I were to say make this a 6, then these two would sum to 6. Maybe they're 1 and 5. Then these two would also sum to 6. Now, they can't be 1 and 5 again because of the added restrictions, so they would have to be 2 and 4. Now, that's not the correct digits because, well, move on from that. Then if I take a look at, let's say, this diagonal here, it has to be 46. So whatever I put along this diagonal, adding all 9 of those digits, it would have to be 46. Now, the harder one here is this middle box here, it being a magic square. That means that every row, column, and the 2 diagonals all sum to the same number. For example, maybe they all sum to 14. So I might go across here and say 4, and I would need to make these sum to 10, so that could be maybe 3 and 7. And I would make this diagonal be 14, this diagonal be 14. Maybe I do that with a 2 and an 8. It wouldn't really work, but then I would also have to make the columns work and the rows work. Now, clearly, the 8 and the 7 doesn't work, so I have some work to do to fix that. But I think that's what we're going to start with, because there's not many options for the magic square. Any rules that you think I need to go over again, Mama?
Nope.
Alright, then let's restart our time. So our time starts now. And the thing that I wanted to take a look at is the fact that pretty much all of these diagonals are fix the zipper lines that are associated with them. So taking a look at this 14 here, that means this has to be a 7, because that has to be 7, and that has to be 7. 16 here means those are 8, plus the 8 in the middle. 18 means I'm going to have 9 and 9. So this is a 9, and 6 and 6 for 12. And that's just seeing that the zipper lines have 2 copies of the sums on each of them. This one being a little bit more complicated because it's the sum itself and a copy of it. But divide that by 2, or divide the diagonal sum by 2, and that gives you your forced value for the zipper lines. Moving on from that, is the center being a magic square. Now, we know that a box in Sudoku sums to 45. Add all the digits 1 through 9, and you're going to get 45. It's a value called triangular numbers. And the triangular number for 9 is 45. Now, with that, that means that each row must be 15. Because you divide 45 by 3, you're going to get 15. Following from there, that means that I have to make 15 6 different ways. So it's going to be the, or rather, the middle digit would be involved with, column, row, diagonal, diagonal. It's going to be involved with 4 different 15s. I don't know where that 6 number came from. And because it's involved with 4 different ways of making 15, then however I place the middle digit is going to leave a remainder that must be done in 4 possible different ways. And the only value that allows for that is a 5. Because I can do 10 in 4 different ways. 1 and 9, 2 and 8, 3, 7, 4, and 6. And they won't overlap. I could try and do 4, which would allow for 11. 11 can be done in 4 different ways. 2, 9, 3, 8. However, 4 and 7 would break, because I've already used a 4 in the center. And if I tried to use 6 to leave 9, which can be done in 4 different ways, you would end up with a 3 and 6 pair duplicating a 6. So the only value that's allowed is a 5. Any other possibility that you try and place in the center doesn't allow for 4 different options to be done to make 15. So with that, I want to consider the value 9. Well, 9 has to pair with 6. So that would be a 1 and a 5, and a 2 and a 4, but what would the third option be? So what that ends up doing is it forces 9 and 1 to be on the column and row with the 5. It doesn't work diagonally. Also thinking about the number 8. Or no, I want to think about the number 7. Or no, so the 9 does the 1 and the 9 in the rows and the columns. Then 2 and 4 ends up being on our diagonals. Well, across from a 2 is going to be an 8. So if let's simplify this a little bit. Let's say I knew that this was the 1 and this was the 9. Then let's say I knew that this was the 2 and that was the 4. Across from the 2, or from the 2 across the 5 is an 8. Across the 4, or whatever, is a 6. Between the 2 and the 6 is 7. Thank you. And the last digit left is a 3. So I end up with odd digits in the row column and even digits on the diagonals. Now to fill this out a little bit more, 1, 3, 7, and 9. 2, 4, 6, and 8. Then the last thing we need to look at in here is the fact that this part here must sum to 5 because it's a zipper line. So 6, 8, 9, and 7 aren't allowed. And I have to have a 2 or a 4 here, and a 1 or a 3 here. Now, that means that this one cannot be a 9, because the 2 or 4 is going to be next to a 9. And this one is not 2 or 4, it must be 6 or 8. And across here is not 1 or 3, and this one's not 1. Now, well, this cannot be. Yes, it could. Never mind. If this was a 7 and a 3, you'd have 2. 2 and 7 is 9. You'd have 6 and 4, and that would all work.
Well, if you look at it with the zipper line, if you have 9 below the 5,
yeah,
then you have to have 1 above it, and that's a 4. And across from 4, or the diagonal from 4 is 6.
So that would be 9, 1, 4, 6.
Well, 9 and 4 and 2 surround the 9.
2, 8, then 7 and 3, and then 4, 6, 2. Well, this one would end up being not a 3, and not a 1, and not a 7. 9, 2, 6, 8. 6, not a 7, and not a 3.
Because those are the only 2 possibilities for what those can be.
Right. Probably made it a little more complicated than I needed to, which is another reason why, like the types of mistakes that I make, like, are just because of the way my brain works, and they don't have to do with the puzzle necessarily. I don't know. I'm probably thinking too hard about justifying like what the how I'm evaluating the difficulty or quality of the puzzle. Okay, well, we know that these are going to be the digits 1 through 5. Not a 5, not a 5. Neither of those can be a 1. Now, these two can't be a 3. Okay. If I placed 3s here, I wouldn't be able to use a 3 in here, because the only 2 3s are these two. So those aren't 3s, they're a 2-4 pair. And so these are the 1-5 pair, and it gives us 3s there. That's not a 3, which means we don't have it being the superscript versions, and our magic square is complete. And just to check, 1, 5, and 9 is 15. 3, 5, and 7 is 15. 2, 5, and 8 is 15. 4, 5, and 6 is 15. 8, 1, 6, 15. 4, 9, and 2, 15. 4, 3, and 8 is 15. 6, 7, and 2 is 15. I didn't do that in any systematic fashion, but no. One of these days I will get around to doing that. 1 through 6. Not a 6, not a 1, not a 2, not a 5, and neither of them could be 3 or 4. One through 7. Not 1 or 7. Not 4. Not 3, not 5, not 6, not 2, and can't put a pair of 4s in there. And these are 1 through 8. Not 9s. 8, 1, 6, 3, 2, 7, 8, 1, 3, 6, 3, 6, 7, 2, 1, and 8. 4, 5 pair means this is not a 4, 5 pair. Now what? Well, 9 has to be one of these two. So it's down here. 7 has to be one of these. Not that one, because of that. So it's one of those. Do we look at the negative diagonal here?
Well,
we know
the 4 empty cells sum to 17.
Right.
Which is a whole lot that they can be.
This corner is 7, 8, or 9. Because it can't be 1, 5, 3, or 2 or 4. Which makes the maximum that these three can be now 10.
Right.
And with these being a minimum 3, that means this is maximum 7. But it can't be a 7, it can't be a 6, and it can't be 1 or 5. So now these are minimum 9, which means these are maximum 8. Doesn't feel that helpful.
No, it doesn't.
Is there something else that we can see? Okay. I don't know if those line up well enough to make any conclusions. Although, learning these can't be 9 means that we end up with 9 in one of these two. Nine's not there or there. Got over here. It's none of those. Can't be there. Meh. Oh, where's 9 in this box? It's not here. Those can't be 9. 9 isn't there. So we get in one of these positions. So that places a 9 in box 1. Now you can put a 9 in the corner. Where else do we need to look? If that's a 6 and that's a 4, you get a 5 and a 2. So that doesn't feel... So you don't have to have a 5. 5, 4... No, 5, 2 would be 4 and 4. I don't have to have a 4. Where can I put 5 in here? well, 5 isn't 3, and I can't put a 5 here because I can't put a 2 over here. So that 5 lines up with this 5 and forces 5 over here, so 5 and 2 is out from those two.
Right.
What can this corner be? It's not 3 or 9, but it also isn't 4 or 5, because these two are different. Okay. This.
Oh.
Go
Where
ahead.
does one go? Where does one go in box 8? It can't go along the bottom, so the ones line up with the ones in box 9. So you can't have 1 8 on the zipper line.
Exactly. So this is either 2 7 or 3 6. But they're next. Because that could be a 1 and a 6, which would remove 1 6 here. But 3 and 4 would have no impact. Same with 2 5. It's not going to have an impact on there. Although 2 would make that a 4, that a 2.
Oh, where does 6 go in box 8?
It's not there. It can't be here because that can't be a 3. It can't be on its own line. It can't be there. So 6 is one of these two. So we get 6 down here, and 6
3 6
and
is
3.
taken out.
So now this isn't 2 or 7 in the lower left corner.
And 7s line up with box 7 and 8, because where does the 7 go in box 8? It's got to go in that section. So 7 is now in the corner.
Right. So now these are 10.
Right.
Because 46 is 1 more than 3 15s. You've got that 15, so now it's 1 more than 2 15s. 6 and 8 are 14. Well, actually, 8 and 7 was a 15, and now it's 1 more than 15. And 6 is 1 more than 5, so that leaves 10. It's a complicated way of getting there.
Yeah.
But it's the way my brain wanted to do it.
Yeah.
Oh, where's 3? Well, it has to be there.
Okay,
that was
now
obvious
those two now add
from
7.
A long time. So 7 comes out. 3 and 4. Yeah, but this 3 should have been obvious a long time ago. I don't know why I had such a hard time with it, because those 3s rolled it out of there, can't duplicate it on there, and obviously that was a 6. So now this is a 3 because of those 2 rolling it out of there, and you can't do it in here. not a 3, not a 5, not a 3. This summed to 7, so not a 4.
Right.
Nine, 4, 8, and 2. Oh, 2, 4, 8 takes 2 and 5 out. 1, 6 makes that a 3 and a 4. 3 and 4. 3, 7, 2, 4, 8. Not a 9. This one's not a 4. So 5 and 9. 5, 9, 4, 7, and 3. This one not a 6. Three, 2, 7, and 9. This one not being an 8. And this one not being a 1 there or there. And they're also not 6.
Well, where do 3 and 4 go in box 1?
Well, none of those are
Or maybe
3.
we should say, where does 4 go?
4
I guess 4
can't
has
go on
2
the 8.
spots.
Can't go there. And that can't be a 3, 4 pair.
So one of those two is 4.
Which takes it out of here. How does that impact here? Well, it's not there. It's not in the top row.
Yeah, it was less helpful than I thought it might be.
3 isn't here. Not there. It's obviously not 8. But it's just around that corner. Because you can do 3 and 5. Can this be 8? If it is, that 4 or 5 is that 4 or 5. So then this would be one of those two. Which would be fine, I think. 2, 4. Four. So that would be 5.
Oh, well, where does 8 go in column 9?
8. Well, 2, 4, 8 means 8 has to be there, so the 8's out of these two. 2, 4, 9 means the
2, 4, 5, 9. Yeah, okay, that works too. Because the 249 is just a triple. The 4 comes out and makes that 168 on bottom of for the 249 and road
Right.
9, yeah.
So 8. So that's 4. And this is 5 because 168. 1,
Right.
not a 4. 5. These two aren't 5, not a 1. This is a 6, which makes that a 2. So 2 and 6 comes off of that. 5 and 3 takes the 3 out of that one. 5 and 6 pairs with 1 and 2.
And there's not a 1.
7 pair. So it's 2, 6. No, 2 and 5 to make 7. Just to double check. 46 here. But that's a 15. That's a 15.
And that's a 16.
Yeah. 9 and 7 is 16. 1 there, not a 1, not a 5. 8. Not 8 and not 6 because 5, 6, 9. So 1, 2, 6 because the 1 there. 7 and 1, not a 6 here. Those aren't situated yet. 2, 7. 7, 6, 9. Not 9, not 2. This is an 8, and this one's not. This column's complete except for a 7, which rolls it out of there, and that's the only spot for a 7 now. These two are 6 and 8. 8 and 6. 2, 4, 5. And 9. And 2, 4 pair takes that out. Leaving behind, 3 and 8. And 8. Not a 3, so is a 3. So that's 4 and 6, I think. Looks like that's correct. 1, 6. These two are 2.
2 and 5.
9 and 1.
One's on the bottom.
5, 9, 5, 6. How about these two? I don't see a 1
and 5.
In that order. These two.
3 and 9.
I need a 4. A 7. 7, 8. This one's not 9, so that should be 9. That should be 6. This is a 2 or an 8. It's an 8. This one's a 2. That's a 4. That's an 8. 2, 4, 2, 7, 4, 8, 7, 1, and 4. If I can press the right button. Alright. That one was a good puzzle. I did
said yay, congrats, but it didn't say it was correct.
Well,
but I would suppose that means it's correct.
Yeah, it would the way that Sven has it programmed, I say as if I know Sven. It would say that it doesn't have a solution attached to it if it wasn't there. So let's search this one up real quick. Magical clock, and that's right here. So just in case we were unsure, column 5, then row 6. Column 5, row 6. Plug that in, submit. Congratulations, you have solved the puzzle. Alright. Hard?
Yeah, it works for me.
the initial logic with it being, the zipper lines were fairly straightforward. The magic square, if you don't already know that logic, can be fairly difficult. Although I don't think it's impossible to work out as long with just like the basic mathematics. It's just addition. So I guess there's a division in there. But it's all like basic mathematics, so it's not a huge deal. So moving beyond that one, I think the thing that I found like that makes it really hard logic is like the stuff that we had to do that was just sort of like, okay, well, where does this value go and what impact does that have up here? And how that was not necessarily super straightforward. There was obviously the 3 that we missed here. That was obvious that like as soon as we got the 3s there. In fact, as soon as we knew that this was a 6, that had to be a 3. Because one of those had to be a 3 pair, which would rule it out of those. So that was a forced 3 as soon as we knew that this was a 6. Not getting it until we got it didn't really impact the puzzle too much, I don't think. Because I don't know if there was that much logic that relied on that. Although, we didn't get it until we got it, so, I don't know. But, like, really thinking about, like, how the 7s here impacted what could go on there and a few other things. And then just sort of working our way up this diagonal. I don't know. It was a little fiddly, but that's not too bad. I think it was a hard puzzle, but it was still a good puzzle. Which again, I'm rating it a little higher than most people are, but that is fine. But yeah, all right. It is just after 10. So, any commentary on any of the puzzles that we solved?
No, I think we took care of it at the time. So
cool. Then anything before we sign off?
Nope.
All right.
Thanks for watching.
Yeah, thank you very much for watching. Stream announcements. There is Sudoku again tomorrow at 8 p.m. Eastern Time. And then Project Zomboid on Thursday and Friday nights, although it's after midnight, so that pushes it into the next day, so pay attention to the times that are listed on YouTube. And then I will try to play Horizon Zero Dawn sometime this week. I haven't played it in the last 2 weeks. Just sort of, when I had the time, I didn't really want to play. So I will try to finish that up. I do want to finish that game. I am enjoying it quite a bit. Outside of that, I think that is all the stream announcements. But I didn't ask you to do the YouTube engagement stuff. So like, comment, subscribe, watch the video 8 more times, put it on replay as you go to sleep. Share the video with your nerdy friends, and challenge them to do the Sudoku puzzles in the description, which I will link here shortly. Other than that, I think, as was already stated, thank you so much for watching, and I hope you have a wonderful day.